This lesson will focus on compound inequalities. A compound inequality is just two simple inequalities joined by the words and or. Examples are listed on this page. In the first example, we have x is less than 6 and x is less than 9. This is an example of a compound inequality. While the second example looks a bit more complicated, it's still just two simple inequalities joined by the word or. In a compound inequality joined by the word or, we say that the compound inequality is true if at least one of the simple inequalities is true. We classify the compound inequality as false if both simple inequalities are false. So for example, if we had a simple inequality, say like 3 is less than 5, or 8 is greater than 9, and we were asked to classify the compound inequality as true or false, we would do that by looking first at the initial simple inequality, 3 is less than 5, which of course is true. And then we would look at the second simple inequality, 8 is greater than 9, which of course is false. If you look back at this first rule right here, it says if at least one of the simple inequalities is true, the entire compound inequality is said to be true, making this compound inequality, of course, true. Over to the right, you'll find a chart that summarizes this. If you let the first simple inequality be the letter P, say that denotes the first one, and the second one is denoted by the letter Q, the chart makes a little bit more sense. So let's look at it. It says that if the first simple inequality is true, the second one is true, then the compound inequality is said to be true. Likewise, if the first simple inequality is true and the second simple inequality is false, like in our example, the compound inequality is again said to be true. It doesn't really matter if you reverse the order of these simple inequalities. We could have 8 is greater than 9 or 3 is less than 5. Still, if one is false, the other is true, the compound inequality is said to be true. The only time it matters is if they both end up false. If they're both false, the compound inequality is false. In a compound inequality with the word and, joined by the word and, the only time this compound inequality is said to be true is if both simple inequalities are true. So for example, if we have 3 is less than 5 again, and 6 is greater than 4, the first inequality is true, the second inequality is true, therefore the compound inequality is true. Again, the chart on the right summarizes this. The first one true, the second one true. The compound inequality is said to be true. If the first one was true and the second one were false, the compound inequality would be classified as false. The first one were false, the second one were true. Again, the compound inequality is false. And if they're both false, of course, the compound inequality is said to be false. Here's a few more examples. -6 is less than 5. True or false? Of course, that is true. And -6 is greater than -3. It is false because it is joined by the word and. The compound inequality would be said to be false. Here we have the connective word or. 6 is less than 5. Of course, that is false. Or -4 is greater than -3. Again, that is false. Therefore, this compound inequality is false.